If you're facing a finance exam in your near future and you have a long list of equations to memorize, the one for Macaulay Duration has to rank close to the top in terms of complexity. Sure, there are other more daunting formulas on your list, but this one stands out in terms of the sheer stress of avoiding unforced errors under exam conditions when it comes to punching the right numbers into the right places in your calculator. Let me show you what I'm talking about. We'll use the formula to calculate the Macaulay duration of an annual pay bond with a 10% coupon rate, 3 years to maturity, and a market yield of 8%. Applying the Macaulay duration formula, we substitute for R, which is the market yield of 8%. And because this is an equation, we need to remember to use decimals, not percentages. So R is 0.08, and the first term on the right-hand side of the equation is 1 plus 0.08 divided by 0.08. Oh, that's simple enough so far. What's the problem? Let's move on to the second term. Minus, and look, there's no hectic mathematics going on here. It is just the sheer volume and intricacy and attention to detail required to get the right things in the right place. So the numerator of that second term, 1 plus R, 1 plus 0.08 in other words, N is the number of periods to maturity, 3 years in this case because it's an annual pay bond. And then in brackets, we have C, the coupon rate as a decimal, that is 10% or 0.1, minus the market yield of 0.08. So the numerator is set up. Turning attention to the denominator, R, 0.08, plus the coupon rate, 0.1, open square brackets. Start with 1.08 to the exponent of 3, minus 1. Close square brackets. And then mercifully in this particular example, because we are on a coupon date exactly 3 years to maturity, the T over T term is 0 divided by 0, so we can effectively forget about that. So having written out the numbers involved, my approach here would be under exam conditions not to try and use calculator memory, but just rather scratch paper or your exam answer book for workings and to solve for that first term, which is 13.5. Fair enough, that's easy enough. Then the numerator resolves to 1.14. And then the denominator, which is the trickiest part of this, to just make sure that you keep calm and get the calculator key presses correct. You're going to be using the Y to the X key, for example, as part of that calculation. We carefully work that out as 0.106. Next, we divide the numerator by the denominator for an answer of 10.7576. The final step is to take the first term of 13.5, deduct 10.7576, and we get our answer using the formula approach of 2.7424 years. So on the face of it, just looking at the calculations on the screen, you might be thinking, that's not an issue for me. And I'm absolutely fine with that. But speaking for myself, I just have found this one to be particularly stressful under exam conditions. And not just remembering the equation, but also then, even if I remember it correctly, I then have to face up to the added stress of making sure that those key presses are correct. So it's just a super stressful situation. But is this the only way to approach a Macaulay duration calculation? Not at all. In the next part of the video, I'm going to show you how a simple timeline can cut through all of this complexity and make your duration calculation much less intimidating. Let's take a step back and use a method grounded in the formal definition of Macaulay duration, which is that it is the present value weighted average of the time to receipt of a bond's cash flows. Each weighting is calculated as a proportion of the bond's price. Now, there's a lot going on under the lid there, but let me break it down for you. This approach, as I hope you'll agree, is much more intuitive, and it also reduces the chance of unforced errors. We set up the timeline, in this case 3 years to maturity, coupon rate of 10, so the cash flows are 10 at time 1, 10 at time 2, and then of course the face value plus the final coupon at time 3 for a total of 110 at that point on the timeline. Step by step, the first cash flow at time 1 is discounted at the market yield of 8%. And using our basic TVM present value formula, we divide that 10 by 1.08 for a present value at T0 of 9.259. Next, and this is the Macaulay duration part of the calculation, and it refers to that weighted average of the time to receipt. So this particular cash flow, its present value has a weighting of 1 because it arrives at time 1 on the timeline. So in purple, we have 9.259 as the number that we are going to eventually use as part of our Macaulay duration calculation. Time 2, we receive the next coupon. We discount by 1.08 squared for a present value of 8.573, and according to the Macaulay duration principle, the weighting of this one is 2. So we multiply that present value T0 by 2 for a number in purple, which will go into our Macaulay duration calculation of 17.146. And then finally, the 110, the last of the cash flows for this particular bond, discounted at 1.08 cubed for a present value of 87.322, and I'm sure you can see the pattern here, times 3, because that is the Macaulay duration weighting for a subtotal in purple of 261.966. Next, we add up the numbers in purple, which come to 288.371. We add up the numbers in blue, which, by the way, are equal to the price of the bond today, which is 105.154. And the final step is to divide 288.371 by 105.154 for exactly the same answer as we achieved using the formula approach of 2.7424 years. So here we have a timeline approach that is much easier and more intuitive to apply than an arcane formula. Even better, it is grounded in basic TVM principles that are already familiar to you. So there is nothing new that you need to add to your already overtaxed memory banks for the exam. And that is it. Thanks very much for watching up until this point, and I will see you in the next Finance Fundamentals video.